We got a plan. We're gonna do it for our Superman. All we see is the goal line to victory. Let you excite you with our display. We won't have a minute. We're going all the way. San Diego, superchargers, San Diego, superchargers, San Okay, I'm going to go this kind of fast because you can review it. If you guys are talking while I'm doing this, I will stop because it means you do not need this, which is fine with me. You can go ahead and do the delta math. You can figure this out for yourself. That's fine. You probably already know how to graph this stuff. So, graph the function. Let's do the 3 easy points. 0, 1, 2. Why do I pick 2? Whatever the base is what I'm going to pick. On the final, it'll probably be something different. But 2. Now, you guys remember how to graph, how to write logarithms? Y equals log 2 to the x. If x is 0, whoops, I'm in the way. I'm writing, so I'm in the way. Write it like this, sorry. If I write y equals log base 2 to the 0, remember, this is my base, this is my equals, this is my exponent. 2 is my base, and log 2 to the 0 equals x. Remember, we take these two, we could flip them. What can I plug in for x to make 2 equal to 0? What exponent? You think the 0 power is 1. 2 to the 1 is 2. 2 to the negative 1 is 1/2. Can I make this 0 by plugging in any number here? Say no. No, it is undefined. So this is no solution. What does that mean if it's no solution? What does no solution mean as far as the graph goes? It's an asymptote, right? So x equals 0, so we got this right here. You guys remember that? And what do we do with asymptotes? You hug them without touching them. So, next let's plug in 1. Let's rewrite it over here. So, 2 to the what power equals 1? 0, right? So it's always going to be, always for every single logarithm, when you plug in 0, again, no solution, when you plug in 1, it's going to be 0. But now here's the last one. 2 to the what equals 2. I should put that as y. What's this going to be? 1. You guys remember? So, let's go ahead and put 0 is no solution. 1, 0. There's that point. You guys remember? And then 1, 2, 1. What's my logarithm going to look like? Well, I'm going to go here in this direction. What am I going to do? The asymptote? Hug it. Got to go through these 2 points. And logarithms always go, woo! It'll be something like that. And that's all you've got to do. We good? You guys remember that? Have I taught you this before?
Yeah. Really clear one.
I can't remember. So much stuff.
Yeah, right.
Vertical asymptote, x equals 0. Yeah, every week. And then there you go, and then boom. Okay. We're almost there. Sure. Which part? The one with I graphed?
Yeah.
There it is. Stay on target, right?
Almost there.
Almost there. Stay on target. Okay. Verify the trigonomic identities.
That's so easy.
Here we go. Okay, verify that sine x times 1 plus cotangent squared x equals cosecant x. Now, what does 1 plus cotangent squared x equal? Someone say it. What does it equal? Cosecant squared x. Any questions? Now, change everything to sine and cosine. I did see some people in test change this to cosecant. Can you do that?
You can.
Sure. Another way to do it, right? I'll do it if we want. However, let's change everything to sine and cosine. This is sine x times 1 over sine squared x, right? And let's go sine x times 1 over sine x times sine x. You don't need to do that step, do you? I'm just doing it so you can see. What happens? Cancel, cancel, which is 1 over sine x, which is equal to cosecant x. And that's all you got to do. Do you guys think you can do that on a test tomorrow?
Is that like part of the graph?
When I say tomorrow, I mean Friday. Yeah, it's part of the graphing. I have one of these trig identities. Even though I call it a graphing final, I thought it'd be fun to have a trig identity verification there.
I feel you.
Can you guys see that there? Determine the complex number. Do you guys remember this?
Yeah.
You're going to love this on your test. I'm going to tell you. Notice this is the imaginary axis. It's not the y-axis. This is the real axis.
After I do that one.
But let's pretend it's an xy axis. How would you write this number? -1, comma, -2. But that's not how we're going to write it here. But you guys understand if this was an xy axis? It's not an xy axis. It's an imaginary axis. It's a real axis. So what we're going to do is the real number is -1. The imaginary number is -2i. And that's all you've got to do.
Wait.
Do you see the similarities? If you can do this, you can do that. Instead of putting a comma, you put an I. Okay. All right, next question. Do you guys remember how to graph this function? I'll give you a second to get it set up. Let's graph this. Everyone have their headphones put away so I pretend like you're interested in this class. Here we go. Okay. First, what are my steps here? First step, set this equal to what? 0. So I'm going to kind of do it this way. I'm going to set it equal like this. Let's see. Okay. It should be able to go away. See how I'm making that disappear? Abracadabra. And so we'll set it equal to 0. What's my next step? Starts with an F and rhymes with tractor.
Factor.
You gotta factor it, right? So, someone said that last period. They said fractor. Okay, is it factored?
Yeah.
Yes. What's my next step? I have to solve for the zeros. So, what are my zeros?
-5.
Zeros are x equals -5 and 2. Are you guys with me there?
No, one thing, I was right. You know what I'm doing. Alright.
Next, I have to solve for the asymptotes.
Shady.
You guys remember what are the asymptotes? Oh, I just realized something as I'm looking at the zeros and the asymptotes. Did you guys realize what I just realized? Do you see that we can flocka? We can cancel out the x plus 5 over the x plus 5.
So we get +2.
So what does that do with my 0 here?
You just have 1.
I don't have, I just have the +2 as a 0. Oh, let's go like that. Let's pretend that that's there. And so I only have x equals negative 1 as an asymptote. But what about the -5? What about the -5? What about the -5? What about the -5? It's a hole,
The whole.
right? You guys remember the holes?
I remember the whole.
You remember what a hole looks like?
Yeah.
So we'll say hole is x equals -5. Are you guys with me there? But that's not the whole. We also have to figure out the y. Okay? So, so let's go ahead and figure out the whole. So let's do a new flip chart here. Let's go to figure out the whole. Y equals x minus 5 over x plus 1. It's not 5, it's 2, isn't it?
Yeah, 2.
Y equals x minus 2 over x plus 1. The whole is that x equals -5. But I have to solve for the y, right? So what do? You plug in -5 into my equation, right? What is -5 minus 2? -7. What is -5 minus 1? -6. So it's 7 over 6. Y equals, did I calculate wrong?
Why does the 1 turn 8?
Oh, was that a positive the whole time?
Come on, Sensei.
Sorry, I made a mistake. And my class corrected me. Remember, I said this is a fake. I'm a fake teacher. I am a fake teacher. So it's -5 plus 1. Is that better, Robert?
Yeah.
And so now this becomes, sorry, I'm in the way of the camera.
Yeah,
So what does that become?
4.
Or, how do we say in Spanish? Negative corazon. So it is going to be y equals 7 over 4, which is approximately what? 1 3/4.
1 and 3, what? 3/4.
Why am I doing that? Because it's easier to graph. You know where 1 3/4 is, more 7/4, right?
Yeah.
So, my whole, remember trying to find the whole.
Yeah.
You guys remember what a whole is?
The whole.
Is
the open circle.
x gets the open circle. X is -5 and y is 1 3/4. Is that what we said? Y is 1 3/4. Okay, let's put everything that we know. Oh, we forgot the horizontal asymptotes. You guys remember those? Horizontal asymptotes. Do you guys remember the horizontal asymptotes?
I don't like you. Look at that.
This is my exponent, right?
Yeah.
This is my exponent in the denominator. This is saying if the m is bigger than the n, like if this is x cubed and this is x squared, then I divide and I get the slant asymptote. You guys remember the slant asymptote? You use synthetic division. You find the x-axis and then you do the x over y. If my m is equal to my n, so this is squared and this is squared. No, you don't divide. Oh yeah, you divide the a divided by d. So if this is 2 and this is 1, it'll be 2 divided by 1. My horizontal asymptote will be at 2. If m is less than n, so say this is 1 and this is 2, then it's on the x-axis. We're going to graph y equals x minus 2 over x plus 1. What's my exponent for this one? 1. What's my exponent for this one? 1. So what do we got?
1.
What is it? M is greater than n, m is less than n, or m is equal to n?
M is equal to n.
M is equal to n. What does it say to do when m is equal to n? M is equal to n.
Divide.
Divide. Whatever the a and d are. What's my a? What's the number in front of x? 1. What's the number in front of x?
1.
What's 1 divided by 1?
1.
Tink, 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 tink. Are you guys with me?
Yes, sir.
Okay, let's put in what we know. Let's do the zeros first, and we'll do the whole. What's my 0? I got 1 at 2. I'll put a point there, and that's the only one I got, right?
Yes, sir.
I have to cross it. I got a 0 at 2. What about my asymptote? -1. So at -1 right here, I got an asymptote, which I'm supposed to do. What is with the asymptote? You hug it. Now, I got a whole at what? -5 and 1 3/4. So down 1 and more than a half, right?
Yes, sir.
So negative 1, 2, 3, 4, 5, and down 1 3/4. Let's draw a hole. It doesn't have to be exact. Are you guys cool? Ready to graph it? We forgot to do test the limits.
That's the limit.
You guys remember testing the limits?
Yes, sir.
Okay, from -1 to here, right? We're testing the limits. What number should I pick less than -1?
0.
Less than -1. -2. -1,000,000?
Yes. It's better.
Thanks. Not necessarily better, but it's easy because -1,000,000 is going to make everything negative. If you pick -2, would I get the same answer? What's -2 minus 2? -4? What's -2 minus 1? -1 is still negative over a negative.
Yes, sir.
And a negative over a negative, I have 2 negatives. What do 2 negatives make?
Positive.
So I got a positive there. Let's pick a number between -1 and 2. What should we pick? 0. 0 minus 2 is negative. 0 plus 1 is positive. I got 1 negative. What do I got? Negative. Let's pick a number bigger than 2.
4.
1,000,000. Can we do 4?
Of course.
Yes. Positive, positive for both of them.
Makes it positive.
2 positives are a
Positive.
positive. Now I have everything that I need. However,
However,
I'm confused because I got a positive.
be happy.
Oh, wait a minute.
Can you figure something out?
It's not working. I made a mistake. Where's my whole?
-5,
-5 and what?
1,
Positive
+1.
should be up here, right? Shall I fix that?
Yes,
Did anyone else catch that mistake? No one said anything.
I did.
Tony did. Sorry, Tony. Was I too intimidating? Am I too intimidating of a teacher? So my whole is 1, 2, 3, 4, 5, 1 and 3/4 right there. That looks better. I was confused because this was supposed to be positive and my whole was a negative, right? So when you're taking the test, obviously you can try to figure things out, pause, maybe go to the next question, then come back to this one. But okay, here we go.
No.
Yes. So I got positive. What am I supposed to do with the asymptote? Hug it. I got to go through my hole, try to keep the hole there, and I'm going to hug that asymptote, and there's that. Okay? Here, I got a negative. So I want to hug the asymptote and go to my 0. And then from here to here, I got a positive, but what about my asymptote? Can I cross that asymptote? No. What do I want to do with it?
Hug it.
Hug it. And then there you go. But wait, there's more.
Oh,
We got to answer these questions. What is my vertical asymptote?
-1.
X equals -1. Make sure you say it's x equals -1. What is my horizontal asymptote?
1.
What equals 1?
Y.
Y equals 1 is my horizontal. Even though it's going like this, it's still y equals 1. 1, 1, 1, 1, 1. It goes that way. This is x equals -1. -1, -1, -1. It's still x equals -1. What is my y-intercept? I don't think I'm going to ask you that, but
Negative.
we could solve for the y-intercept by plugging in 0 for my x. 0 minus 2
No.
over 0 plus 1. That's how we find the y-intercept. What's 0 minus 2? -2. What's 0 plus 1?
1.
-2 over 1. -2.
No.
So, I guess it would really go right here. It should cross right here. If I was to redraw it. Let's get that y-intercept in there, shall we?
It doesn't be.
I got my 0 at 1, 2. And my y-intercept at -2. So we can draw this at, to cover both of them, let's go like this. Go through here, and go through there. Now I got it at 2. X-intercept. What's my x-intercept? Actually, let's write my y-intercept as y equals -2. What's my x-intercept? X equals what? +2. And what is my whole? -5 and 1 3/4. My whole, which we solved before. And there's all the information that you need for that graph. So the y-intercept, make sure you plug in 0 for x. That's all you got to do for that. Plug in 0 for x to solve for the y-intercept. That's algebra. That's math 1 stuff.
Math 1.
Is it? It's a math 1 skill. Do you guys remember math 1? Find the component form of this vector. Oh, where's the arrow? Where's the arrow? Oh, there's no arrow. Let me fix it. Okay, find the component for this vector. Remember, component form is q1 minus p1 comma q2 minus p2, where q is the initial point and q is the, oh, I gotta change that. What is q supposed to be? Not the initial point, but the terminal point. This is the terminal point. Let me change. Where q is the terminal point. Okay, so we're going to go 3 minus negative 1, comma, 5 minus negative 1, which will be positive, 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 positive. Remember, we write it as 4, comma, 6. So if I ask you the component form, what I'm going to ask for you next? You guys, the magnitude.
So it'll be 16 and 36.
So, find the magnitude. Magnitude is, or since I have the component form of 4 comma 6, all I got to do is 4 squared plus 6 squared, and then I take the square root. 4 squared plus 6 squared, and I take the square root, which is 16 plus 36 square root, which is 52? Square root of 52. Now let's find the 52 is 2 and 26, right? 26 is 2 and 13. So 52 is 2 times 2, I'm in the way. 2 times 2 times 13. Who gets out of jail? Flink, flink, flink. 2 root 13. What do you guys think? No problemo? Light? Graph 2 periods of sine. All you guys get set up for this one? What's my A? 1. You guys remember that? What does that tell me? How far up and down it goes from the midline? What's my B? 1/2. What's my period? How do I figure out the period? Period is what? Period is 2 pi over B. Right? You guys remember that? Or 2 pi over 1/2. Or 2 pi divided by 1/2. Or what? You don't need me to do all this. 2 pi times what? What's the reciprocal of 1/2? 2. What's 2 pi times 2?
4 pi.
4 pi. So my period is
4 pi.
4 pi. What's my H? 0. Nothing in the parentheses. What's the most difficult trig function to graph? Is when you have an H. Does this have an H?
No.
Is your test going to have an H?
Hopefully no.
If I don't have it here,
No.
probably won't be on your test.
Oh, thank God.
Do you guys know me? Oh. All right. show that they're there. They are clapping for me. Even though I'm a fake teacher. Fake teacher! What's my K?
-2.
Okay, what does that mean, the -2?
That's the one that moves it.
The midline. So let's put that there. That's easy. Let's get that. Okay. Let's also do our 5 key points where our period ends at what? 4 pi. So let's go 1, 2, 3, 4, 5. This ends at 4 pi. My 5th point is 4 pi, right? You guys with me? What's half of 4 pi? 2 pi, our favorite artist. What's half of 2 pi? 1 pi. So each of these is 1 pi. 1 pi, 2 pi. What's this going to be? 3 pi. Okay. This is sine, right? So I'm going to graph my 5 key points. Wait, hang on here. We have everything. The -2, the A is 1. I think we're good. Let's graph our 5 key points for sine. Where are my zeros for sine? Which key points? Tell each other in the group. What are the... Here we go. Did you guys, anyone know what's sine? What are my 3 zeros for sine? Now remember, my midline's here. It's the first point is 0. The last point is 0.
The middle point.
And the middle point is 0. You guys remember that for sine?
Yeah.
Do you remember what cosine is? Because you might see cosine on the test.
It's the first, the third,
Second and fourth. Second and fourth. So, what do I go in between? What do I do? Up or down? Up. Now, how far up do I go? This says I go up 1. Then I go down 1. And then how do you connect the points? Make them curvy. Now I asked you to do 2 periods. I don't know if I'm going to have you go front or back, but let's go back. Here we go. Let's do periods over here. 1 pi, 2 pi, 3 pi, 4 pi. So then I go, what's this going to be? -1 pi. I got -2 pi. I got -3 pi. I need 5. 1, 2, 3, 4, and -4 pi. There's my 5 key points. Let's go ahead and do it. Starting here, it's sine, right? What are my zeros? First, last, middle. Then I go up 1. I go down 1. And you make it curvy. Let's do another period going this way, just for the heck of it. What? You guys have questions? Let's go this way. Let's do 5 more. 1, 2, 3, 4, 5. 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. Okay, 5 key points. First is 0, last is 0, middle is 0, then I go up 1, and I go down 1, and then there's another period. You'll have to do only 2. Do the eyeball test. Does it look okay? I think it looks okay. Or did I miss? Right here. Look at this. I missed this one right here, right? It should be here. Oh yeah, look at that. So look, but you guys see what I did wrong? So this was easily correctable. But how did I notice it was wrong? By doing the eyeball test. I said, whoa, that doesn't look right, right? So anyway, this should have been, I know. Should I fix it? Should I get it together? No, I'm not. I got to rewrite the whole thing. So much work. Negative pi. That's like you guys, huh? Negative. I should make life easier for you. I make life so hard for you guys. Okay. So I got, help me here. So I got first, last, and then now I can't. 1, 2, right here, middle, right? Now this should go here, right? Is that right?
No, it goes down. Oh yeah, no, that's.
No, but
No, it goes up. No, it goes up.
no, it goes up. Let's start here. I gotta go up. I just want. Is it lined up with this, right? Is it lined up? I think that's good. Does that look better?
Kind of.
Oh my gosh! Forget it. I'm moving on.
Wait. The 5 points.
Oh, 5 key points.
1, 2, 3.
5 key points. We got 0, pi, 2 pi. As you can see here, right? 0, pi, 2 pi, 3 pi, 4 pi. 1, 2, 3, 4, 5. What do I have at 0? -2, right? 0, -2. What do I have at pi? -1. 2 pi, -2. 3 pi, -3. And then 4 pi. Did I record that? It's recording, thank goodness. Thank goodness.